Okay, and as usual, we'll take a look at Math Breeze to see what's new. So we have some new things up here. That's Thursday. We have assignments due. I'll just look at what it is. Okay, so this is what we're doing today. And this as well. Actually, we did this already. This is what we're doing today, 043. And then we'll start 044 today. So you have those two due. Okay. And then we have 044, 045 due on Monday. If we don't complete it, I'll revise this. But for now, hopefully they'll be due on Monday. And then I set a date for exam 2. So that's a week from Thursday. And it's sections 032 through 046. Okay, that's through graphing, curve sketching. But really all of this is curve sketching. We're really doing it, a lot of it we're sort of doing, I consider this to be almost like one chapter. You know, everything has to do, it all has to do with graphing. All right, so let's look at this first example. And we're looking at increasing and decreasing functions and what we call the first derivative test. So far we discussed increasing, decreasing. And here's the basics. If your function is increasing, that happens if and if the derivative is positive. Okay, so increasing means derivative positive, and decreasing is the same as derivative negative. And this is sort of intuitive, you know, if you look at just a picture like this. Here we have increasing. From left to right, this function's going up. It's always from left to right because that's the direction in which x is increasing. So the function is increasing here. Let's say if this is f of x. And you see the slope here is a positive slope. So here it's increasing, and we see that the slope is positive. And over here it's decreasing, and we see the slope of the tangent line is negative. So it's sort of intuitive that this should hold. Okay, so this is what we saw last time. And here we want to know when a function is increasing or decreasing. So what we're going to do is we want to see where f prime greater than 0, and we want to see where f prime less than 0. Oh, I see. Okay, somebody said exam on Thursday. We don't have class on Thursdays. You're right. You're right. We don't have class on Thursdays. Maybe I'll change it to Wednesday, okay? All right, so I'll see next time. I made a mistake there. You're right. I could change it to Wednesday. All right. Okay, so what we want to do is we want to see where f prime's increasing, where f prime's decreasing. In fact, let me make myself a note about that. Okay. Okay. All right, so all we have to do first, take f prime to start with. Okay, bring down the 3x squared, so that becomes f prime is x squared. Here, bring down the 2, and we have 2x. Sorry, we have x. When we bring down the 2, it cancels with that 2 in the denominator, so we just have x to the 1 plus 2. So that's the derivative. Now, to see where it's positive or negative, we're going to do a plus-minus analysis. Okay. We're going to put the zeros on the number line, put where this is equal to 0 on the number line. Put zeros on number line. And look in between the zeros to see if it's positive or negative. Okay, so that basically outlines the plus-minus analysis. If we have a denominator, we have to put zeros of numerator and denominator on the number line. So we'll have an example like that as well. But anyway, let's just let's just see where this is equal to 0. Okay, so we're going to factor it. So this factors x minus 2, x plus 1. Okay. So here I'm writing f prime next to it, just as a reminder that we're looking at doing a plus minus analysis of f prime, not of f, but of f prime. So put f prime here just as a reminder. So here put in order the zeros of this. This is equal to 0 at minus 1 and at 2. And I just substitute in things in between, like something bigger than 2, like 3. We substitute in 3, we get 3 minus 2, and here we get 3 plus 1. They're both positive. Here, between minus 1 and 2, we have 0. If we substitute in 0, 0 minus 2 is negative, and 0 plus 1 is positive. Just a minute, this f prime. Just 1 second. I'm substituting in 0. Now somehow if I substitute in 0 here, I get 2, which is positive. I'm getting a little, let me just look at this one more time. Okay, this is, that's right. Minus 1, 2. Substitute in 0, we should get negative. Something's wrong here. F prime, that's a plus 2. X squared minus x plus 2. Okay. We substitute in 3, we get positive, positive. Substitute in 0, we get negative, positive. This should be negative. Okay. Oh, yeah. Okay, sorry. This is a plus 2, sorry. I have to change this example. All right, I meant this to be a minus here. Let me see in my original notes. Yeah, I think I just copied wrong. That should be a minus. Okay, I'm sorry. We have to go back and change this. This should be a negative. So let me do this correction here. So then this is negative. All right, now that's the right factorization. Okay, we have minus 2 times 1 is minus 2. And the middle term, we have a minus 2x plus x gives us a minus x. So, okay, that's corrected. All right, so if I plug in 0 here, I get 0, 0, minus 2. I get a negative. Okay, so that's okay now. All right, now let's something to the left of minus 1. Let's say we plug in minus 2, and here we'll get a negative, and here we'll get another negative. Negative times negative is positive. All right, so this is f prime. So this tells us that f is increasing here, f is increasing here, f is decreasing here, and increasing here. Okay, so we wanted to know where is it increasing, decreasing. So we could say increasing on this interval, which would be minus infinity to minus 1, and also this interval, 2 to infinity, and decreasing on in between minus 1 to 2. Okay. All right. Okay, so that's our first example. All right, now let's suppose we want to find out when the function's increasing and decreasing. Like, let's look at this function here. This function looks something like this. If I draw, okay, if I draw the xy axis, and here at minus 1, it's going to, here we have minus 1. Well, let me actually, I don't want to draw the xy axis like that, quite like that. I'm not going to put in x-intercepts. I'm just going to say, let's say on the x-axis, let's say here we have -1 and here we have 2. I don't know exactly where this function is in relationship to the x-axis, but I know that it's increasing until we get to -1, then it starts decreasing, and then when we get to 2, it increases. Okay. So it looks like we have, this is called a relative max, and this is called a relative min. Relative meaning relative to points near it. Like for example, this is a high point, but if we go up here, continue along on the curve, we have higher points. But relative only to the points around it, this is the max. And this one also, this one's the minimum in this little location relative to the points around it. But here, down here, we do have points that are smaller than this y value. We have y values that are smaller down here. But that's why it's called a relative max or relative min. Okay. So let's say if we want to find relative max and relative min. All right, I'll write it out. Relative. Okay. Also called local. And here's the procedure. So first we find critical values. Of f of x, and that is where f prime equals 0, okay, or f prime does not exist, but f continuous. We have to have an example like this. We don't have one like this yet, this piece. So far, the only critical values we found were where f prime is equal to 0. We'll have just a few examples of the other type of critical value. So find critical values. Okay. Do a plus minus analysis. Do a plus minus analysis of f prime of x. Okay. And then if we have, let's say if we have a critical value c, if we have this pattern, let's say a positive to the right, negative to the left pattern, that means the function's going down here and up here. In other words, let's say we have that pattern, then that means we have a min. You can see from the picture it looks like a min. Okay, so this is called the first derivative test for max min. Or if we have this pattern, positive, negative, then from left to right it's going up and then it's coming down. That's f's going up and down. That means we have a max. Okay. Or if we have positive, positive, or if we have negative, negative, doesn't change, okay, then it's neither. Like you can see here, negative, negative, it doesn't go up or down or up. It'll be neither, not max or min. This is called the first derivative test for max min. We're analyzing the first derivative. Instead of relative max, relative min, we just abbreviate it max min. So if we look at what we saw above, it's easy to see what the situation is here. Just from the way it looks, you see up and down, this one's a max. That one's a max. Down, up, this one's a min. You see that one's a max, and that one's a min. All right, let's do a full example, another example, where this time, instead of asking where's the function increasing and decreasing, we're going to have two parts. Where is it increasing and decreasing, and find the relative max min. So here we have, here's the function. And this will help us with graphing. All right, so what we want to find here is find where f increasing and decreasing find max min. And let's say we want to find the x and y coordinates, the full point for the max mins. All right, this is all done in one plus minus analysis. They're two separate questions, but it's done together. Okay, so what we do is first critical values. Okay, f prime of x equals 0. That's what we're going to solve. So here 5 times 3, so we have 15x to the 4th minus 60x squared. And we want to solve this. Where is it equal to 0? All right, here I see we can factor out 15x squared. And here we have x squared minus 4. Okay, so just factor that again. X plus 2x minus 2. Okay, so now we're going to solve this. Okay, so this piece, x equals 0, we get from here. From here we get x equal minus 2. And from here we get x equal 2. And these are all critical values. Now for the plus minus analysis. Of f prime, which will answer both questions. Increasing, decreasing, max, min. It answers both. Put the zeros of f prime and the places where f prime doesn't exist. In this case, f prime exists everywhere on the number line. In this case, we'll just put critical values on the number line for the plus minus analysis. Basically, we put zeros of numerator and denominator, but there's no denominator here, so it just ends up being these critical values. So we have minus 2 in order, minus 2, 0, 2. Okay, so we're ready for the plus minus analysis. Just substitute in values. Here's f prime. Sometimes it's good to write f prime underneath, just for substituting in. It's nice to have it here so we can look at it. Okay, so let's say we substitute in 3. We have positive, positive, positive. If we substitute in 1, we have positive, positive, negative. So that the whole thing will be negative. And if we substitute in minus 1, this is still positive. And here we have positive, and here we have negative. So 1 negative, so again negative. Notice the pattern did not switch. We didn't switch from negative to positive here. And that's because of the x squared. All right, we got 0 from this piece. And because of that exponent 2, we broke that alternating pattern. Any even exponent will break the alternating pattern. All right, let's put in the minus 3. Positive. This is always positive because of the squaring. Negative when we put in minus 3. Negative. Negative times negative is positive. All right, that's our plus minus analysis. And now let's put our arrows in. Increasing, decreasing, decreasing, increasing. So you see this critical value is neither. This one's max, up and down. We don't have to memorize, just look at it. We don't have to memorize positive on the left, negative on the right means max. Just look at it using your arrows. Here, look at this using your arrows. We're going down and up. This looks like a min. And this one's neither. Now, if we want both coordinates So the graph comes up and down. It has that high point at -2, and the y value will be f of -2. Don't forget to substitute into f. That's going to be a point on our graph. So here's f over here. Just substitute in -2. So we have 15 times 16, -2 to the 4th, minus 60 times 4. Okay, so I'll just work that out. Okay, 1 second. I'm just going to work that out with my calculator here. So we're just doing 15 times 16. Okay, so I have 240, and then 60 times 4. One second. Oh, sorry. You know what I did? By mistake, I substituted into f prime. Very common mistake. So let me, because that's what I had showing up here. So I have to substitute into f. Okay, so be careful not to make that mistake. Especially if you end up getting 0 for y, then chances are you made that mistake. Because that's where f prime is equal to 0. Okay, here. Okay, so we have 3x to the 5th minus 20x cubed. Okay, so that's what we need to do. So this is minus 32. 3 times minus 32. So we have minus 96. And here we have two negatives. It's going to be positive. So it's going to be positive 40. I'm sorry, this is 8. Positive 160. Okay, so I get minus 264. Okay, so this is our high point on the graph. So if we were to actually graph, it's useful to find the y-coordinate. So we can plot the high point. And this one, if we substitute in 2, okay, we get 3 times 2 to the 5th minus 20, 2 cubed. Okay, and that's just going to be the negative of the other one, so that's going to be 2 minus 64. Okay, so this one's our max and this one's our min. All right, let's look at another one. So that's basically a full problem. All right, let's look at a different type. This time I want to have one with a denominator. See what number is this? This is number 2. Let's go to number 3. I want one with a denominator. It's just a little bit different. So I want to do this one. Okay, so again, we want increasing, decreasing, and max min. Okay, derivative, we need a quotient rule here. Square the denominator, put the denominator up here. Derivative of the numerator is 2x, and then there's a minus sign. Derivative of the denominator is 1, then the numerator is x squared. Okay, let's just simplify this. If I multiply out 2x times x, we have 2x squared, minus 2x times minus 5 minus 10x, minus x squared. Two x squared minus x squared, so we have x squared minus 10x. We want to know where this is equal to 0, so we're going to be setting the numerator equal to 0. So I'm factoring the numerator. Remember, a fraction that's reduced is 0 when the numerator is 0. So we want to solve f prime equals 0, set the numerator equal to 0. Okay, so we have x equals 0, x equals 10. Okay, now plus minus analysis. These are critical values. Okay, so one important thing that I'm pointing out in this example, and you'll see in a minute, on the plus-minus analysis. Okay, for plus-minus analysis, we put down zeros of numerator and denominator. Okay, so for the numerator, we have 0 and 10. And for the denominator, we have 5. Now, this is important. You see, for 5, I have an open circle. Okay, open because, not f prime, because f does not exist here. Okay. We will have not f prime, f, because really we want to get information about f. Okay, so that's important, that little nuance, open circle because of f, not because of f prime. Okay, plus-minus analysis is pretty straightforward. Put an 11. Okay, here's my f prime, put an 11, and we have positive, positive. The denominator is always positive. Okay, so positive because of the squaring. Put in a 6, let's say, and we have positive, negative, and this is always positive, positive, negative. Okay, so that's negative. Okay, let's say we put in 4. Okay, this is always positive, and here we have positive, negative. So again, negative. And then less than 0, is that minus 1, let's say, and we have negative, negative. Negative, negative makes positive. Okay, so here we have increasing, decreasing, decreasing, okay, increasing. So here we have max min. Now this one, I'm not even going to write neither next to it. This one was not even a possibility because of the open circle. Okay, so even if it were increasing, decreasing, even if it looked like a max or looked like a min, it would not be because of the open circles. A reminder, never can't be max or min. Okay, even if the arrows went into a different pattern. Okay. So max mins can't happen. Let's just write it down. No max min if well, no max min at point not in domain. Okay, so that open circle reminds us that it's not in the domain. So to figure out now the y-coordinate, plug in 0 back into f. Let's not make that mistake before. 0, we'll get 0 over 0 minus 5. So we'll get 0, 0 here. And then 10 back into f, and we get 100 over 100 minus 5. We're plugging in over 10 minus 5. Okay. All right, so we have 100 divided by 5, so 20. Okay. Again, that's f of 0, and this is f of 10. So that's the whole picture. Okay. Okay, let me give you one to do. I'm going to start it off because I picked this one out of the book, out of a different book, but we'll start you off. So we want to know max min and increasing, decreasing. Again, that's just plus minus analysis. That's where we get it from, of f prime. Okay, so I'm going to start you off. Derivative 4x cubed minus 12x squared plus 8x. All right, we're going to factor out, we can factor out x and 4. So here we have x squared minus 3x plus 2. All right, it's a good one. I just want to make sure that we didn't have to use the quadratic formula here. This does factor. So just, you continue with this. Factor, put all the zeros on the number line. Okay, so you're going to do plus minus analysis of f prime. So you finish this. I'll just give you like a couple minutes and then we'll do it. Okay, if you get the max, I think this one has 2 mins and 1 max, I think. Okay, if you get the max, put it in the chat. You can just put the x value of the max in the chat. Okay, I'm going to factor this. Okay, so right here, this factors x minus 2, x minus 1. Okay. So from this we get critical values, 0 from here, 1 from here. Oops, I said x minus 2 and I wrote 1. Okay, 0 from here, 2 from here, and 1 from here. Okay, just put them down in order. 0, 1, 2. All closed circles, because f exists at 0, 1, 2. Plus minus analysis, just plug in. We're going to have that alternating pattern because I don't have any squares here or fourth powers. No even powers. We're going to have just an alternating pattern. Okay, you got it. Okay, great. 2, so you got 1 max and 2 mins. Okay, that looks good. All right, great. Okay, so let's look at this. All right, we'll plug in here, plug in 3, and we have positive, positive, positive. Plug in 1.5, and we have positive, negative, positive, so 1 negative. Plug in minus 0.5, and we have negative, 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 sorry, minus 0.5, we have negative, negative, minus 0.5, minus 1. Just 1 second. There should be an alternating pattern. Sorry, not minus 0.5. It would be, over here would be 1/2. Plug in 1/2, 0.5. Just 0.5. And if we plug in 0.5, okay, so it's positive, negative, negative. So 2 negatives, so that would be positive. And if we plug in a minus 1, we have negative, 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 3 negatives. So there's our alternating pattern like we anticipated. Okay, down, up, down, up. Okay, min, max, min. Min, you see how down and up? Min, max, up and down. Just the way it looks. And this one goes down and up. It looks like a min. Okay, we plug back into F. Okay, plug in 0, we get 0. Okay, 0, 0 is a min. Okay, I see that's what you got. And we plug a 1 into here, and we have 1 minus 4. That's minus 3 plus 4. So we have 1. 1 minus 4 minus 3 plus 4, 1. 1, 1 is a max. Okay, good. And we can plug in 2. Okay, plug in 2. We have 16 minus, I'll just write it down here. 16 minus 4 times 8 minus 4 times 8 minus 32 plus 4 times 4 plus 16. I see we get 0. Okay, and that's it. Okay, very good. You got all 3 correct. So that's great. All right. Okay, so this is a typical problem, and I really want to do one with the denominator. So let's do another one with the denominator. The difference is in the plus minus analysis because we have to put the 0 of the denominator. So here, let's look at this one. Okay, I think we'll do x squared minus 9 over x minus 1. Let's try this one. Okay. So again, we're looking for max min, and we're looking for increasing, decreasing. Okay, first f prime. So quotient rule, x minus 1 denominator squared. Put the denominator over here. Derivative of numerator minus derivative of denominator is 1 times the numerator. Okay, simplify. 2x squared minus 2x minus x squared plus 9. Okay, let's just, what do we have here? We have x squared, and we have x squared minus 2x plus 9. All right. Okay, I'm not crazy about this example because the zeros of the numerator, we have to use a quadratic formula to find the zeros of the numerator. All right. On the test and even on homeworks, this usually does not come up. So I'm just going to do it quickly on the side, but usually you won't have this extra step. Okay, so quadratic formula, we have negative b, so we have 2 plus or minus square root b squared, that's 4, minus 4ac, that's 1/9. Okay, over 2a. All right, so in this example, notice this is negative. 4 minus 9 is negative. Let me just make sure of that because that's important. B squared minus 4ac, that's 4 minus 4ac. I left the 4 out. Let me do it again. Write it. It still is negative. Okay, b squared minus 4, a is 1, and c is 9 minus 4ac. This is very negative. 4 minus 36, okay? So this is negative. Okay, no real solutions. All right, so no max min for this. Okay. If we were to do the plus minus analysis, then the top is never 0. We just put the 0 from the denominator. Okay. And if we're to substitute in, let's substitute in something to the right of 1, like 2, for example. We substitute 2 into here. We have 4, and here we have 9. That's 13 minus 4. We get something positive. And the bottom is positive because it's squared. We're substituting into f prime. Okay, if we substitute in, let's say, so there I substitute in 4. Let's say we substitute in 0. That's an easy one to substitute in. We get 9. And here we have something positive. So we have positive. All right. Okay, so that's the plus minus analysis. F prime F is increasing. Okay, at this point, I'll just say at x equal 1, we have a vertical asymptote because the denominator is 0. Here, go back to F. See, vertical asymptote here. Okay. All right, let's see what time. Okay, let's look at another. Again, just I want to do an example, simple example, where the derivative doesn't exist. So here's an example. Where we have a critical value of the other type. Okay, so first we're going to find critical values. Let's just do that to start with. So let's do f prime of x. 2/3, and 2/3 minus 3/3, subtract 1, 2/3 minus 3/3, you have minus 1/3. Let's write it like this. Okay, like that. All right. This is never 0 because the numerator is never 0. And this does not exist when the denominator is 0, when x equals 0. But f is continuous at x equals 0. There's no problem here when x equals 0 because we don't have a negative exponent in f. The negative exponent we have here, you see, in f prime. So because when we substitute in 0 here, x flipped to the denominator, all right? F prime does not exist at x equals 0, but f does. Never 0 does not exist when x equals 0, but, and this is the important but, f is fine at x equals 0, f continuous at x equals 0. So when you have that situation, and this is where it comes up with these fractional exponents in examples that we'll see. That implies that x equals 0 is a critical value of the other type. Let me just scroll back up for a second and just to the definition of a critical value. Critical value f prime equal to 0, or f prime does not exist but f continuous. So this is the second type that we don't come across very often. So here's an example of that type of critical value. And this is actually a min. If we would, we'll do a plus minus analysis and see it's a min, but here's the graph. Sort of comes to a point at 0. Okay, that's 0. Okay, so I'm just showing you what the graph looks like. There you have a min. F prime of 0 does not exist. F of 0 is fine. Nothing wrong with f of 0. Okay. All right. So in other words, f continuous at 0. That's the other type of critical value. So if we wanted to find now max min, so we do plus minus analysis of f prime, and the only thing we put on the number line is 0. Now notice I have a closed circle. Closed circle. Since f, no problem with f of 0, okay? Here. So really we go by, even though we're doing a plus minus analysis of f prime, the open closed circles go according to f, not according to f prime. That's the important little nuance here. All right. Now we're substituting into f prime. Where's f prime? It's right here. So if we substitute in something bigger, like a 1 bigger than 0, we get positive. Substitute in a minus 1, and we have, this is a negative 1 when we substitute in minus 1, so we have negative. Down, up, it's a min. Substitute in 0 into f, and we get 0. There, 0, 0 is a min. So that's a simple example, really, of the other type of critical value, how you can have a minimum at the other type of critical value, and how you find the other type of critical value. So that's typically what happens. Very often it involves a fractional exponent where you have x in the numerator here, like not in the denominator, but when we take f prime, it flips to the denominator. So that's typical for an example that has the other type of critical value. So we'll only come across a couple of these, not too many, but that's one of them. Maybe we'll do one more that's more complicated. All right, so here's a more complicated one. But like I said, for the main, let me see, I think you have one like this in the homework. Let me check the homework. Yeah, you have one like this in the homework. Okay, so we'll just do one last one of this type, a more complicated one than number 6. All right, that'll help you do the one in the homework. So again, we want to find max min, increasing, decreasing. Same thing. These fractional exponents, that's sort of a hint that we might get a critical value of that other type. Okay. All right, so let's do f prime. 5/3 x, subtract 3/3, so here we're left with 2/3. Okay, minus 5x, subtract 3/3, here's the negative 1 coming in. All right. Let's write this as x to the 2/3 over 1, and here we'll put the x to the 1/3 in the denominator. Now what we're going to have to do, we want to find when this is 0. So we'd like to write this as a single fraction. We do this a lot when we have two fractions and we want to set some function equal to 0. We'd rather have one fraction so we can set the numerator to 0. Okay, remember, fraction 0 and numerator is 0. But here we have two fractions. Let's combine so that we have one fraction. So we're going to do a common denominator. Common denominator is going to be 3 times x to the 1/3. So here we have, let's write it again, 5x to the 2/3 over 3 minus 5 over x to the 1/3. Let's get common denominator is going to be, just multiply those like that. Okay, so here we're multiplying top and bottom by x to the 1/3. So on top we have 5, and notice when we add these exponents we get 1. Okay, so here we have a question, why didn't we multiply 5 with the exponent? Okay, I just want to see. Let's see, over here we brought down the 5. I'm not sure which line you mean. Here we brought down the 5. 5 times 2/3. Okay, let's see. Okay, right here. All right, let me just look at it. Okay, here. Oh, 2/3. We get. Okay, so I think you're right. We did have to. We brought down the 2/3, and you're right. So here we do have 10 over 3. Okay, so I did miss that. 10 over 3 here. Thank you for the correction. I wouldn't want that to stay like that, so I'm very happy you corrected me. Okay, so here we have 10/3. Bring down the 2/3. So we have a 10/3 here. Okay, x to the minus 1/3. So let me correct that throughout. So this will be 10 over 3 here. Okay. So then we have to put the 3 down here. And the 10 on top. I'm just continuing to correct this. Okay, so the common denominator is still 3 times x to the 1/3. This one has the common denominator already. So look what happens when we multiply by x to the 1/3. These, when you add these, you get x to the 3/3, which is 1. So we just get x over there. And here we have minus 10. Okay. All right. And we want to know when is this equal to 0. Well, just set the numerator to 0. Five x equal 10. And we have x equal 2. So that's our critical value. Okay. On f, oh, sorry, wait 1 second. We have 2 critical values. That's the point here. We have to see when is the numerator 0 and when's the denominator 0. To find the critical values, we have 2 types of critical values here. First, where the numerator is 0. All right, 2. Okay, and the second one is a place where f prime does not exist. See, this flipped to the denominator. So f prime does not exist at x equals 0, but nothing's wrong with f of 0. I'm going to write it like that just to shorthand. Nothing's wrong with f of 0. So this is another critical value. So this is a critical value type 1, where f prime is equal to 0. And x equals 0, critical value type 2. Okay, f prime does not exist, but f does. Okay, just shorthand over there. All right. So plus minus analysis, we're going to put both zeros of numerator and denominator on the number line. So we're going to put 2 and 0. So 2 goes there, and 0 goes here, and the important thing is close dot, okay? Close dot, since nothing's wrong with f of 0. All right, so this could be, we're not removing it from the possibility of max min. It could be a max min, we're including it. That's the important thing here. The closed dot, we're including it. It might be a max min. All right, let's now do plus minus analysis. We're looking at this for plus minus analysis. Put in 3, and we have positive, positive. Put in 1, 5 minus 10 is negative, and the bottom will be positive, negative. Okay, let's put in minus 1, and we have the top is negative, the bottom is negative, 2 negatives, so positive. Okay, then just draw these arrows. And we see that this one's max. So this is the max of the other type. The pointed max, you could think of it, and this one's a min. Okay. And this one, I'm not going to substitute in, but you could substitute in to find the y value. All right, so this is one of the more complicated types where we are finding a max min at a place where the derivative does not exist. All right, so you have one like that in the homework. It's the one where you have a fractional exponent. You'll see one problem where there's a fractional exponent. And I think you do a similar thing to we did here. Okay, for f prime, you end up with, I think that it's the same thing, 2 fractions, and you have to combine them. Common denominator and combine them into a single fraction. Then look at the numerator and look at the denominator. Okay, just like we did here. Okay, so use this as an example, as a model. You can always ask me questions on how to do that problem. Okay, any questions? Okay, so we'll stop here. Okay, and we'll finish up some more tomorrow. When is the exam? I think I wrote it on MathBreeze. I think I wrote, oh, right, I wrote November 12th, so maybe it'll be the 11th. Let me just look at what we have left to cover and decide if the 11th is okay. If not, I'll push it off to the Monday after. Okay, so I'll tell you tomorrow about when the exam is. Okay, any other questions? All right, so look over these notes and start doing your homework. You can email me a question. All right, and I'll see you tomorrow.